Given four vectors here relative to a fixed origin O, in fact, we're working in two dimensions. We're asked, first of all, to show that AD is parallel to BC. So let's work out what AD is. Now, the quick way to remember it is that it's the position vector going to the second one minus the position vector for the first one. We can draw a little diagram to demonstrate this. So let's say we've got an origin and we've got A and D. Then we've got OA and OD. So to get from A to D this way, we could go AO, which is our minus OA, they're the same thing, plus OD, hence OD minus OA. I quite like to write them in column form. I just find it a little bit easier. So I'm gonna go ahead and do that. 22, 24 minus 12, 0, which gives 10, 24. And then we can do the same for BC. It's going to be OC, 50, 136, minus OB. Okay, this time it's a J, so there's no I, but there is a J term, which is going to give 50, 120. We're trying to show that AD is parallel to BC. So if two vectors are parallel, that means they're going in the same direction, and they'll just basically be scalar multiples of one another. So I can see I've got 10 in the first one and 50 here. So if I factorize a 5 out, I'm actually then going to divide through by 5, so I get 10 and 24. And that's all I need, basically. I've just shown, so therefore BC is equal to 5 AD. Or we could say that AD is a fifth BC. Hence, I mean, I don't think we need to write any more, like they are scalar multiples, it's implied by all of it. So hence AD parallel to BC. Great. We're now told that A, B, C, D are used to model the vertices of a running track in the shape of a quadrilateral, and runners complete one lap by running along all four sides. The lengths are measured in meters, and a runner takes 5 minutes to complete 2 laps. Let's calculate their average speed. So we've just shown that AD is a fifth of BC. Let's say I've got A here and D here. So then I'm going to be going down in some direction, but then I'm going to draw a parallel side. Okay, I'm actually going to create a trapezium. It's in fact going to be like much longer at the bottom. It's not perfectly to scale, but A, B, C, D, there we go. Let's work out some of the side lengths. So we've already got the vector AD. We can therefore work out the length, 10 squared plus 24 squared square rooted. Use Pythagoras. 26. We could do the same for BC, but actually we've shown that the vector is 5 times as long, so we can just times 26 by 5, 130. Now I need to find out the lengths of the vectors A, B, and DC, so I'm going to need to actually calculate what they are. So AB or BA, you can find either one, is going to be OB, that's 0, 16, minus 12, 0. So I get minus 12, 16. Okay, we'll work out the length of that in a minute. Let's just work out, go with DC. The reason I'm actually going with DC, originally I did CD, but it's just a little bit easier because C has slightly larger numbers. So it's OC, which is 50, 136. It's not going to matter if you do it the other way around. Minus 22, 24, which gives 28 and 112. So length of AB will be minus 12, whoops, didn't mean that, minus 12 squared plus 16 squared, square rooted. You can actually ignore the minus. So 400 square rooted is 20. And then 28 squared plus 112 squared, square rooted. Which is 28 root 17. I kind of thought, oh, is it going to be a whole number again? But in fact, it's not. It is a surd. We're nearly there. So that means that we need to find the total length of the track. So just add them all up. Actually, it's not too bad to do this without a calculator. So 176 plus 28 root 17. Okay, the only thing I've got to do, we're trying to work out our answer in kilometers per hour. So at the moment I've got it in meters, and actually it probably is just easiest at this point to get it as a decimal. So 291.446. And let's now change it into kilometers. Divide through by 1,000, 0.291446. The time of 5 minutes, we need to get it into hours. So it's just 5 over 60, or 1/12. Okay, and therefore average speed is going to be the total distance divided by the total time, distance over time. So we've got 2 times 0.291446 because we were told that they completed 2 laps of the track in 5 minutes. Divide that by 1 over 12, which is actually the same as timesing by 12. I'll do it. Dividing 1 over 12. And we get 6.9947. Okay, that is the speed in kilometers per hour. Doesn't say what accuracy to give it. So I'll write down it to 3 significant figures, 6.99 kilometers per hour.